Today we're going to talk about the difference between science and pseudoscience. I view this as one of the most important lessons that you will learn in this class. In fact, I think that this is really the real reason that I think you should have to take a science class. You might find it uninteresting, but as an educated citizen, you really should be able to discern the difference between real science and pseudoscience. You may also feel concerned that studying science can be somehow in conflict with your religious beliefs. Be assured that many scientists are deeply religious and find that these two areas of their life can coexist quite easily. They do not have to be in conflict, and we'll explain that in a short amount of time. First of all, let's take a look at the hallmarks of science. Here we see the three hallmarks that you probably saw in your book. First of all, you're going to look for explanations for observed phenomena that rely solely on natural causes. No hocus pocus allowed. Science also will progress through creation and testing of models in nature that explain the observations as simply as possible. In Civ, you might have learned about Occam's razor. Occam's razor says that if you're presented with more than one explanation of how something might be explained, you have to pick the simplest explanation. Here you see that we also observe that in science. Finally, science makes testable predictions about natural phenomena. If predictions do not agree with observations, the model must be revised or abandoned. This is very important. In science, we have to be able to test if our hypothesis is true. Also, if we find results that tell us that our hypothesis does not appear to be true, we have to revise it and move forward. Here's the cycle of the scientific method that you probably learned about in grade school or middle school. We start with observations, which lead us to some fundamental question about nature, which then we form into a hypothesis, which we called an educated guess. We then have to say, based on a hypothesis, what would we predict in an experiment, and then test through that experiment. The results of our experiment will either show us that our hypothesis is supported or that it is not. If it's not, we have to revise it, and so the cycle goes. Don't get too hung up on the scientific method. Remember the basic hallmarks of science to be able to identify it. Remember, no hocus pocus can be used to explain a natural phenomena. Remember that the models have to be created and tested, and models that offer simple explanations are preferred. Also, remember that your theories or hypotheses have to be testable. If future evidence indicates they're incorrect, it's back to the drawing board. Hard to believe, but in science, we can't allow for the ego to interfere with the process. And also, we never really prove that our hypothesis is correct. Just because we haven't been able to disprove it doesn't mean that in the future, with maybe a different test or more technology, that we might find that our hypothesis in the future actually is proven to be incorrect. So, what are some unique characteristics of science that make it science? Well, the thing that I just talked about, that it's always open to change, there are no absolutes, that's a characteristic of science. This is one that troubles people. Often I hear complaints about reports, scientific reports that are reported on in the literature, or in media, for instance. Is it good to drink coffee? Is it bad to drink coffee? Is chocolate good for you? Is chocolate bad for you? And we're bombarded day by day on results that seem to contradict each other. And so this could be viewed as a weakness of science, but it can also be a strength, because it means that in science we're very open-minded, and we know that at any time our ideas could be modified or changed. It also is nice that in science the process is designed so that it isn't being overly driven by someone's agenda. It shouldn't really, the investigator's personal beliefs really shouldn't be influencing how the process is moving forward. Finally, this is very important. There are not two sides to a scientific hypothesis. A hypothesis is not a debate. Case in point, global warming. We are often presented in the media that there's a debate about global warming. There's no debate. The hypothesis, up until now, has been proven time and time again. So don't be fooled. We don't have debates in science. We only have a hypothesis that has either been proven or disproven. The difference between theory that we use in our everyday language and how we use it in science is something that's important too, to recognize that in science it has a very particular definition. A theory is a hypothesis that has been tested over a long period of time and at this point is still not been disproven. So it's been supported again and again. An example is the theory of gravity. It doesn't mean that it's an absolute. I mean, someday maybe we'll have to modify our theory of gravity. But remember that this idea of theory is quite different than if you say, I have a theory about why the PC basketball team is so good. You don't mean a scientific theory. You just have an idea. Now, non-science. What is that? Well, non-science is when you seek out knowledge through pure intuition, societal traditions, ancient scriptures, and other processes that make no claim to adhere to the scientific method. Well, if you're thinking that this sounds like religion, science, non-science and religion are in the same category. So this is what I meant in the beginning to say that your scientific ideas and religion don't have to be in conflict because they're in separate categories. In non-science, because there's no effort to conform to the scientific method, then as scientists we shouldn't judge it because it isn't science. It isn't our thing to judge. It's something different. Now, pseudoscience, that is something that is different because pseudoscience, as the name implies, is false science. And so that it might seem scientific, but if upon closer examination, it really does not adhere to the testing and verification of the scientific method. So what are some characteristics of pseudoscience? First of all, it has a hypothesis that cannot be tested. If you can't test the hypothesis, then you're not going to be able to follow through with the method of science. Another characteristic is when only part of the data is used to support their hypothesis. We call this the cherry picking of data. You can't cherry pick your data. You can't select only the data that supports your hypothesis and ignore everything else. Unfortunately for a scientist, he has to look at everything, and that's why sometimes he has to revise. Sometimes a pseudoscience will make statements that sounds like they're scientific, like they sound really complicated. It must be science. They might use titles or organization names that make it sound valid, like the Institute for Creation Research. Sound familiar? There's also often a sense of paranoia associated with a pseudoscience. They'll say that they're being attacked by others. They'll say that there are conspiracy theories against them. Conspiracy theories are one of my favorite types of pseudoscience because people really seem to go for them, and I just don't understand why. But be aware, they are pseudoscience. And finally, the last characteristic, which you probably can't see, is that a pseudoscience will not have its work published in a peer-reviewed journal like a scientist will. They'll be published in popular media, maybe just online. The fact that it hasn't been peer-reviewed should set off an alarm clocks in your head. I have a link here to a conspiracy theory video, and I'll put it under our lesson builder on this week's lessons. You might want to take a look at it. As we conclude, I want you to think about the relevance of the reading assignments that I gave you this week for the topic of science versus pseudoscience. You can also think of what are some examples of pseudoscience that you read about in your bad astronomy text. Finally, can you answer the question, if the Institute for Creation Research is advancing the idea of creation, why aren't they considered immune to the judgment of the scientific community? Is this science attacking non-science, or is science attacking pseudoscience? Think about it.